So in this video, we're going to do a few more examples of molarity calculations. And you'll see us essentially the remaining videos for this lesson, just a bunch of practice problems to be able to do and comprehend our molarity calculations and preparing solutions from solids using the weighing method. So do make sure you go through each video, try the problems out yourself first, then go to the video and see if you were on the right track and you got the right answer. Check your answer with the filled in version as well. So let's go ahead and try this example out here. How many grams of solute are needed to make a 500 milliliter solution of cobalt 2 chloride dihydrate that has a concentration of 0.12 molar? So we sometimes put big M over here to represent moles per liter. I know it often refers to molar mass as well, but when we use it as a unit, it can be written as big M rather than moles per liter. So we need to find the mass. So for example, if I were to tell you in the lab, I need 500 mils of solution, that's 0.12 molar. You have to figure out, okay, well, what does that mean in terms of mass that I have to go weigh on a balance? Because here we told you that mass, but sometimes I tell you the concentration and you got to figure it out. So remember, the concentration is equal to C is equal to N over V. And we want to find the mass. Now, we can't find the mass with this formula, but we can find the moles. So we can rearrange this and get moles is equal to C times V. So this is kind of our plan. We're going to try to get that. And then after that, once you have moles, well, remember, you can find the mass, right? So our plan would be to use the moles we find there and multiply it by the molar mass to get the mass at the end. So that's our goal. So that's our planning. That's our step one. Let's write out also what we have. So we have our volume is 500 milliliters. It's only one sig fig, which is equal to 0.5 liters because we want to have it in liters. And we're actually given our concentration this time. Concentration is 0.12 moles per liter or molar. Okay, so we can do that in step two. We can say that N is equal to C times V because I just sent V to the other side here. And it becomes a multiplication since it was divided on that side. So that's going to be equal to 0.12 moles per liter multiplied by the liters, so 0.5 liters. Cross out liters, and so you're going to have 0.5 times 0.12, and you'll get 0.06 moles. Now our step three is to do the mass is equal to moles times the molar mass. It is important you know the molar mass. So we have cobalt 2, not cobalt 2 chloride, but cobalt 2 dihydrate. So we have CO, cobalt 2 chloride dihydrate. So it's 2 H2Os there. So let's go ahead and find the molar mass of this. So molar mass of that is equal to, so there's two waters, so 18.02 times 2 plus chlorine, 35.45 plus 35.45 because there's two of them, plus cobalt is 58.93. And I get 165.87 grams per mole. So I can do my moles, 0.06 moles times 165.87 grams per mole. Cross out moles, and we get grams left over, so times 0.06. And we get about 9.9522 grams, which is approximately, we need to go to one sig fig, because here we had one significant figure. So, and this is 2 here, so 1 is the smallest number of sig figs there. So it looks like we're rounding up to about 10 grams. So therefore, approximately 10 grams of the cobalt 2 chloride dihydrate are needed to prepare this solution. And so you could sketch this out again. I recommend you practice sketching every time, or at least a couple times. So you would basically be weighing out your 0.1 grams of the cobalt 2 chloride dihydrate, putting it into your volumetric flask, adding distilled water until it's half full, shake to dissolve, add distilled water up to the etched line, put a cap on, shake to make sure it's nice and dissolved thoroughly, even though it's already done in this previous step. And then you can go and store it in some other container or use it as needed. So that there was our example of using this equation, but in a manipulated form. And this is actually probably one of the most practical ways you'll do it because, like I said, in the lab, you'll be asked to make certain concentrations of solution and a certain amount of them. So if I say, okay, well, for this lab, I need you all to make 500 mils of a 0.12 molar solution, you need to know, well, how much of that do I have to weigh out to put in the flask? And so that's the method you would use to figure that out here. So let's take a look at another example over here. The solution shown above contains 90.0 grams of our ammonium dichromate in enough water to give a final volume of exactly 250 mils. So we have 3 sig figs there and 3 sig figs here, just to identify that early. What is a molar concentration of the ammonium dichromate solution? So where's that picture exactly? It's right over here. This is the picture that's referring to. I just didn't put it in the handout. So you can take a look at that there. So let's go ahead and try this out. So we want to find, this is just a regular concentration problem, but we're given the mass to begin with. So our first step, let's write out what we need. We need concentration is equal to moles over volume. We have our volume, which is 250 mils, so 3 sig figs, which is about 0.250 liters, so still 3 sig figs. We don't have our number of moles, but we do have our mass. Our mass is 90.0 grams. So we do need to find our moles. So we know that mass is equal to moles times molar mass. So the moles are going to be equal to the mass over the molar mass, which is going to be equal to 90.0 grams over the molar mass of that ammonium dichromate. So ammonium is 14.01 plus 4.04 times 2, because there's 2 of them there, plus the dichromate, so 2 times 2 chromiums, so 52, 2 times 52, plus 7 oxygen, 7 times 16. So that would be about 252.1 grams per mole. Cancel out the grams there, and we get 0.357001119 moles. So now that we have that, we can simply do C is equal to N over V, which is equal to 0.357 moles. Everything's still in my calculator. Divided by the volume, 0.250 liters. And we get 1.428000476 moles per liter, or molar you can write with the big M. But we need it to 3 sig figs, so that's approximately 1.43 moles per liter. Then you can write a therefore statement. So therefore, the concentration of the NH4 to Cr2O7 is approximately 1.43 moles per liter. And let's go take a look to see if we are on the right track with that using our filled in version over here. Yep, 1.43 moles per liter to the proper number of sig figs, which was 3. So in the next video, we're going to do some more practice problems from the next page, but do make sure you can do the ones that we did on the first page here, or on page number 2, the first page of problems, very well, and then you can move on to the next ones.